This conference will now be recorded.
Hello. How only I'm talking now? Am I audible? Yes. Okay, very good morning to all. Today we are going to look at few more important concepts of Unit 1. Before getting into that topics, what we have seen in the last class is biosignals, biosignals classification, and sources of biomedical signals. Okay, so biosignals is nothing but the signal which we are going to extract out from the human body. Correct. So, biosignal classifications, it is classified based on the nature and origin. Chemical, uh, electrical, mechanical, acoustic. These are a few classifications under its nature, and its origin classifications are endocrine system, digestive system, nervous system, skeletal system, nervous system, and the cardiovascular system. Correct. So many systems are there under the origin classification. Okay, auditory system, sensory systems, visual system. Okay, many systems comprises inside a human body. And now we are going to look at how signals are taken out of human body. Okay, the signals taken from the living object is said to be biosignal. So here the agenda of today's session is biosignals, neuron, electrical activity of the cell, biopotential, electrode potential, half cell, motion artifact, electrode skin interface. Okay, so as we know the clear concepts of biosignal, it is taken out from the human body. Living object level, if I'm taking signals out, then that is said to be biosignals. Okay, so next is what? Neuron. Okay, did you see this diagram previously? Could you able to figure it out where it is located in our human body? This is neuron. I have given you the hint in the previous sessions. Neurons are there in dash of human body. Have you heard the term neuron? Neuron is different, nephron is different. Neurons. Not aware of neuron? Okay, so let me explain you. Neuron is nothing but is a unit of brain. Okay, this is a cell which is present inside your brain. So yes, present in brain. Dharnita, right? Very good answer, Dharnita. Good. So this cell is present in human brain. Okay, so we have mitochondria, cell body, dendrites. This is myelin sheath, node of Ranvi. This is what your axon terminal. Okay, so this is n number of millions and millions of neurons are present inside a human brain. Okay, so what is the application of this neuron is? It is used to take all the control signals and passes it to other parts of the body from the brain. Okay, this is the fundamental unit of brain. Okay, if this neuron will not work properly, you couldn't able to think or do any actions which is supplied by your brain. Okay, so each and every neuron, okay, will be interconnected with the other neuron so that the signal will be passed from one neuron to another neuron. We are having millions of millions neurons present inside our brain. Okay, so what is present inside the neuron? So we have positive and negative charges. Okay, so positive and negative charges are present in the neuron. As you can see here in this example diagram, you will understand what is present inside the neuron. We have negative charges and positive charges. Okay, when these two are combined with each other, then it makes an action potential. Okay, when these two are separated by each other, that is said to be resting potential. Okay, is it clear? So each and every neuron are interconnected with the help of your dendrites. Okay, in the end of, is it clear? This is called dendrites. In the dendrite la irundhu da innor neuron ku it will be connected. Okay, the signal which is generated in this particular neuron will be passed to some other neuron through this dendrites. Okay, so next is what? Electrical activity at cellular level. Okay, how electrical activity will be taken out from cell, each individual cell. Okay, electrical signal, that is bioelectrical potential, are extracted by means of biosignals. Okay, so electrochemical activity of the certain class of cells are known as excitable cell. So you know already the word excitation. Okay, so when you look at some laboratory, electronics laboratory, we are telling like excitable state, the component is in excitable state அப்படின்னு சொல்லிருப்போம். கரெக்டா? You could have heard that excitation is nothing but ஒரு electrochemical activity. Okay, செல் வந்து ஆக்டிவா இருக்கிறதுக்கு பேர் தான் எக்ஸைட்டட் ஸ்டேட்னு சொல்லுவோம். சரி, அது எப்போ ஒரு செல் ஆக்டிவா இருக்கும், or எப்போ ஒரு காம்பனன்ட் ஆக்டிவா இருக்கும்? when I'm going to suppose to give some power supply to the particular electronic component so that it will become active, correct? That state is said to be excitable state. So components of nervous, muscular and granular tissues. Okay, இது இங்கிருந்து நான் என்ன பண்றேன், சிக்னல்ஸ் வெளில எடுக்கிறேன். என்ன சிக்னல்? எலக்ட்ரோகெமிக்கல் ஆக்டிவிட்டி சிக்னலா நான் வெளில எடுக்கிறேன். ஓகே, ரெண்டு கிளாசிஃபிகேஷன் ஆஃப் எக்ஸைட்டபிள் ஸ்டேட். ஒன் இஸ் வாட்? ரெஸ்டிங் ஸ்டேட். another one is action state. Okay, acting potential or resting potential சொல்லுவோம். And the next comes, this diagram shows how it is excited, how it will be converted from resting state to excitable state. Okay, so this is your individual cell. We have discussed the cell and its components in the first class. Okay, mitochondria, chloroplasm, cytoplasm, lysosomes, everything we have studied in the first class itself. So take that cell as an important thing in the calculation of biosignal. Okay, so this is your single cell. This is your single cell. Each and every cell has charges, positive charges and negative charges. Okay, this is your cell membrane. Inside your cell you will have negative charge and outside of the cell you will have positive charge. Okay, the cell is connected to some external voltage, minus 70 milliwatt external voltage. What happens when we are supposed to give voltage to this particular cell? What happens? We are having potassium and sodium present in the cell. Okay, so your sodium and potassium are important thing which fills your liquid inside the cell. Okay, so liquid மாதிரி இருக்கிறது வந்து chemical substances present in the cell to make your cell active. Okay, so if I'm supposed to give some voltage to that particular cell, what happens? என்ன நடக்கும்? It will do some reaction, right? Yes, it will do some reaction, obviously. Okay, so this positive and negative charges will move from one place to another when I'm supposed to give some external source to my particular cell. Okay, this will happen. Okay, some charges will move from one place to another place. What happens if charges will move from one place to another? Moving of ions. Okay, inside our cell we are having ions. So and the ions movement la நமக்கு ஒரு charge create ஆகும். That charge is called your potential. Okay, so what is potential? Potential, it is like an voltage. Potential difference na voltage னு சொல்லுவோமா? அப்போ electronic components la we are taking a potential difference, that is voltage. Okay, அதே மாதிரி if I'm going to make a charge out of my cell, that is said to be your biopotential signals. Okay, under action state. So this is polarization of cell, this is depolarization of cell, and next we have repolarization. Finally, action potential. So what is polarization? We are not giving any input to my cell. We are just connected in the first diagram. Okay, this is polarization. The positive and negative charges remains in the same place. And in the second diagram, we are depolarized. The signals from inside and outside of the cell membrane will move from one place to another. Okay, that is sodium and potassium. That is depolarization of cell. Next, we have repolarization of cell. So what is depolarization? I'm going to take the signal out of your cell. And next we have action potential. Action potential measures what are all the potentials developed by your individual cell by the movement of ions present inside that cell. Okay, so here various resources of biopotential. So what are all the sources of biopotentials? We are going to place electrodes. Okay, as you can see this diagram, these things are called electrodes. Okay, so this is electrode which is placed near your eyes to measure your eye movement. Okay, this is electrooculography. Okay, this is used to measure your eye movement and activeness of your eyes, pupil, retina, everything. Okay, and next comes with this is your electroencephalogram. Electroencephalogram is nothing but we are having n number of electrodes which are going to placed over the skull. Okay, that skull placed electrode will grab the signal from the brain and it will connect it to the computer. Okay, the placement of this particular electrodes uh, or should be properly placed in the proper places. Okay, we should not place the electrodes wherever we like. There are some coordinates to place the electrodes over the skull. Okay, similar way we have some electrodes which we are going to place over the chest. So this is called electrocardiography. Okay, from this electrode I am going to extract the biosignal from heart to diagnose whether we have any diseases present in the heart or not. And finally, here we have a galvanic skin response. Okay, so this is CSR, which is clipped with the fingers. Okay, that is also called electrodes, and which is used for measure the oxygen content present in the blood. And next, we are having some non-invasive sensing. Okay, so this is used to measure some pressure gauges and all, pressure things and all. We can able to take out from this finger. And we are having another sensor which is used for taking muscle activity, that is electromyogram. Okay, if we are going to analyze the muscle, we go for the technology called electromyography. If we want to measure the activeness or the performance of the eyes, and we should go for electrooculography. And if we want to measure brain activity, then we go for electroencephalogram and graphy. And if we want to measure or test that heart rate, heart function, then we should go for electrocardiography. Likewise, each and every part of the body can be tested using these electrodes, because electrodes are used to taken out the biosignal from the particular organs. Okay, so these are all various sources of biopotentials and bioelectric signals and their characteristics. Okay, as I told you earlier that electrocardiogram, it is vectorcardiogram, electroencephalogram, cerebral potential, electromyogram, electrogastrogram, electroretinogram, electrooculogram. Okay, retino and oculogram are used to check the eye activity. Okay, for vision activities, right? Gastrogram is like digestive system measurement. Okay, testing of digestive system, electrogastrogram. And we have electroencephalogram, brain activity, and ECG, cardiac muscles. Origin is cardiac muscle, neuron activity, cerebrum of the brain, cerebral potentials, and we have skin muscles, electromyogram. Okay, peristaltic movements of the gastrointestinal tract, retina and cornea of eyes. Okay, that is electroretinography and oculography. So what are all the electrodes used for taking out the signal from those places? So that is surface electrodes. We have many electrode classifications: surface electrode, needle electrode, depth electrode. Okay, so out of that we are using surface electrode to cover maximum space present in the chest part, so that I can take heart rate, heart function properly through my electrodes. So this is surface electrodes, and the voltage range is 10 to 5000 covers fetal range, and frequency range 0.05 to 1000. And similarly, encephalogram 0.1 to 100, and voltage range is 2 to 200. Surface electrode can be used or needle electrode can be used. And finally, as to the cerebral potential, pulse duration 0.6 to 1 0.1 seconds, and voltage duration is 10 to lakh. Okay, deep needle electrode, because cerebral potential, cerebrum is present inside your deep skull, so I should go for needle potential. Okay, and needle electrode potential, and electromyogram 5 to 2000 frequency range, 20 to 5000 voltage range, that is microvolt, and surface and needle electrode can be used. And for gastrogram 0.05 to zero point 0.2 and 10 to 350 surface electrodes can be taken, and electroretinogram 0.01 to 200 hertz and 0.5 to 1000 microvolt corneal electrodes. There are some electrodes called corneal electrodes. Okay, so next we have oculogram. So we are going for miniature surface electrodes. Okay, oculogram is used to measure the corneal activity, so we can place that miniaturized electrode in the lenses itself. Okay, yesterday we have studied some vision system, right? Visionary system. So in that visionary system we have placed electrodes in the lens where the person is using. Okay, that lens output will be taken to my differential amplifier output. The output taken from the lens and the threshold value should be equal. If there is a mismatch in the signal, then we have troubles in the vision. Okay, that is how the physician will diagnose the patient. And next is what biopotential electrodes basics. Okay, so what is the fundamental thing to take biopotential electrodes? That is the interface between the body and the electronic measuring device. It is like an interface between the body and the measuring devices, because the signal will be taken from the body through the electrode to the measuring devices. Okay, so next, conduct current across the interface. So we are having some interface between your human body and the electrode. Okay, so in raw body, in raw skin, it will never take the signal out. So for lubrication, we are going for some paste and gel. Okay, so that the signal will be taken properly out of my organs to my electrode. Okay, the current conduction across the interface. Next we have current is carried in the body by ions. Okay, so ions will be present inside a human cell. Potassium ions, sodium ions, we have many chemical ions present inside the human body. Okay, human cell. By the movement of those ions, we are getting potential signals. Okay, so current is carried in the body by ions, so we are getting signal out of the movement of ions is said to be biopotential ions or biopotentials. Okay, next, current is carried in electronics by electrons. So current in the electronic gadgets, the current is carried in movement of electrons. Okay, and electrodes must change ionic current into electronic current. So now I'm taking ionic movement, ionic current from the body through my electrodes, and I'm going to convert that into my electronic current. Okay, this is all medicated at what is called electrode-electrolyte interface and electrode tissue interface. So we have two interfaces. Okay, so we can call that interface like electrode-electrolyte or electrode tissue interface in syndrome. So yeah, so this is basics. It is very easy. We are going to place electrodes and also we are going to paste some gel-like thing between your skin and your electrode, so that proper ionic movement will be absorbed from the particular organ, and after taking that ionic current, we are going to convert that into your electronic current. Okay, this is simple basic concepts. And next is what purpose of electrode paste. As I told you earlier, there should be some lubrication between the electrode and the skin surface. Okay, so to remove some of the outer cells in the layer of the skin. So we have some dry skins, we have some dead cells present in the outer layer of the organ. So that we are going to remove that things by using this electrode paste. Okay, we have more connection, we have more contact region by using this electrode paste. Okay, it is also used to reduce artifacts. So artifacts is nothing but, in medical term, artifacts are called disturbances, sudden movement. Okay, so disturbances of the electrode or patient. If we are going to observe something from the organ, the patient should be remain in the same place, or their placement of electrodes should be stayed in a proper place, remains in proper place. If the movement of electrode or the patient will gives artifacts, that is disturbances of measuring signal out of human body. Okay, artifacts is nothing but disturbances. Next, electrode contact impedance varies with fat content, blood supply and pressure applied. Okay, so this impedance of the electrode will be varied from place to place. That is, if we have more fat content present in the body or improper blood flow, then we couldn't able to get proper signals. Okay, so these are all important things for applying your paste. And this is your conductive material. Okay, this is the paste where biomedical signals will be extracted, and it acts as an interface between electrode and your body. The material where the paste is manufactured or taken out is anthracite or coal tar pitch. Okay, carbon paste electrode CPE is made from a mixture of conducting a graphite powder and pasting liquid. Okay, you could able to hear that a graphite conducts electric current. Pencil வந்து கரண்ட்ல வச்சேன்னா பென்சில் வந்து கண்டக்ட் பண்ணும். Circuit boardல வச்சேன்னா your pencil will conduct current. Okay, how it is conducting current? Because the material where we are manufacturing, where we are creating the pencil is your graphite. Correct? Black color இருக்குல்ல lead, that is graphite powder. Okay, so that is a material where we are going to create this paste. Electrolyte, we called it as electrolyte. And YouTube videos for action potentials are here listed in this particular slide. You can view the related videos for muscle action and action potentials present in the human body. And the basic thing how action potential and resting potential will be defined. Okay, so in the resting potential we are having positive and negative charges across the cell membrane when it is not involved in an impulse. Okay, so there is no movement of ions present in the cell, that is said to be resting potential. The cell is under resting state. Okay, because it will not do any work, it will not create any ionic movement. Okay, so what is action potential? It is a state of cell membrane while in an impulse. Okay, the measure of rapid polarization and repolarization of cell membrane is said to be action potential. So from the diagram you can see here, this is your resting potential. Okay, there is no movement of ions between your external thing and internal membrane. Correct? Positive charges are present outermost body, and negative charges are present inside your cell. So there is no movement, no combination exchanging of things present over here. This is said to be resting potential. When it comes to this diagram, we are placing a sodium. Okay, when we make our cell excited, we are having potassium and sodium will move from one place to another. Okay, so here the sodium potassium pump here, it will move the ion in and out of the cell through cell membrane. So once you have movement of ions between in and out, you will have ionic current. Okay, so here cell membrane potential will be explained a little more clearly, right? This is your resting neuron. Okay, negative particles present inside, positive particles present outside. When we are going to give or excited, okay, the sodium and potassium ions will move from one place to another. Your potassium and sodium will be positive charge and your chlorine will be negative charge. Okay, so these ions will move from one place to another, so that it will create ionic current. So this ionic current will be converted into electronic current with the help of electrodes. Say for example PN junction diode. Okay, what happens in the PN junction diode? We have P material and N material. You all could understand this concept, PN junction diode concept. Correct. So when you go for P type material and N type material, this is P and N, PN junction diode. You have studied in first year itself. PN junction diode, I am going to connect this diode positive and this is negative. This is under forward biasing. Okay, this is your potential. Okay, whenever I am increasing the voltage, what happens? Positive charges from P type and negative charges from N type will move from this place to this place. Correct? Negative charges move from this place to this place and positive from this place to this place. Correct? Under forward bias only your PN junction will conduct. Because PN junction diode is a semiconductor, I'm going to make the semiconductor into conductor by the application of my input voltage. Okay, this is my input voltage. By the application of this only, my semiconductor is going to convert into conductor. Okay, so it is like the triggering source of PN junction diode. Okay, so once we increase the voltage, there is a recombination of your positive charges and the negative charges takes place. Here you have depletion region. Okay, so this is the depletion region between PN and N junction. And when we increase the voltage, what happens? The moment of positive and negative charge destroy or eliminate, okay, this depletion region. Okay, this depletion region will vanish and it starts conduction. So likewise here in your neuron, okay, in your neuron we have positive and negative charges. When we have some action potential, okay, so there will be an ionic moment. When we have resting potential, there will not have an ionic movement. How the ions are moving from one place to another? Because of excitation, the positive and negative charges moving from inside and outside of your cell. Okay, so that ionic movements takes place. That ionic movements are grabbed by your electrodes. Okay, this is the fundamental concept of biopotential. Okay, we have two classifications of potential. One is action potential, another one is resting potential. Resting potential, the cell will not do anything. Action potential, the cell will getting charged and discharged. It is like a capacitor. Okay, so it will gives me an ionic moment. So action potential, you will get polarization, repolarization, everything. Okay, the action potential is a temporary reversal of the polarity charge inside the cell compared to the outside. So here you can see this diagram. This is resting state. After application of some excitation, your cell will having ionic moment, that is repolarization phase. Okay, so after repolarization, maximum ionic moment, it comes back to the original place. The state where it going to comes back is called repolarization phase, and again it reaches my resting state. Okay, so this is undershoot. The signal which belows the resting state is said to be undershoot. Okay, resting state, no potential generator, excitation applied to the cell, depolarization takes place, maximum point reached, it comes back to the resting state. The starting state of my resting state will be repolarizing, and it is undershoot, which is lower than your resting state. Okay, this is graphical representation of your action potential. And next comes the same. Okay, so already I have told you, right? So threshold of excitation, here sodium channels open, sodium begins to enter the cell. In that potassium channels open, potassium begins to leave the cell. Sodium and potassium plays a major role in ionic movement. Okay, and here we have sodium channels becomes refractory, no more sodium cells enter. And here potassium continues to leave cell and cause membrane potential to return to the resting potential. Here K plus channel closes, Na plus channels rest. Sodium potassium avanga place ku vandiruchu, so resting potential maarichu. Seriya? Doubt irukka? Do you have doubt? It's simple as like your PN junction diode. Right, thank you. No doubts. Next, biopotential electrodes. Okay, so in order to measure recording potentials, we are going to provide some interface between body and the apparatus. Okay, so here we are having biopotential electrodes is a transducer, because I'm going to convert ionic current into electronic current with the help of electrodes. Okay, so the current carried in the body by ions, where it is passing through your electrode, and it is taken out as electrons in the electronic circuits. Okay, the ionic moment current will be converted to electronic current with the help of electrode. The electronic current represents the movement of electrons. Okay, so this is what done in biopotential electrodes, and this is given in two processes. One is oxidation and reduction process. Electrode-Electrolyte interface will be done in two. One is oxidation and the one is reduction. So in oxidation, reaction causes atoms to lose electron. Okay, so atom to lose electron lose பண்றனாலயோ உன்னோட கெயின் பண்றதுனாலையும் எலக்ட்ரானை கெயின் பண்றதுனாலையும் உனக்கு என்ன கிடைக்கும், ஒரு ரியாக்ஷன் கிடைக்கும். அந்த ரியாக்ஷன் பேர் தான் electrode-electrolyte interface. Okay, so here you have electrolyte have positive charge and metal have negative charge. Example க்கு கொடுத்திருக்கு, electrolyte having positive charge and metal having negative charge. What happens in oxidation? It is going to lose electrons. Oxidation la I am going to lose electrons. In reduction la I am going to gain electrons. Okay, so the oxidation and reduction produces some electronic current. So half cell or electrode potential. So half cell potential is determined by metal involved. The same example. Okay, electrode metal interface. A certain mechanism separate charges at the metal electrolyte interface results in one type of charge is dominant on the surface of the metal and the opposite charge is concentrated at the immediately adjacent electrode. Okay, so the gaining and losing of electron plays a vital role for getting cell potentials. Okay, so this is electrode potential is also called half cell potential. Okay, losing of electrons and gaining of electrons from the electrolyte to metal and from metal to electrolyte. Next, polarizable and non-polarizable electrodes. Okay, so we have two classification of electrodes. One is polarizable, another one is non-polarizable. Okay, so what do you mean by polarizable? The polarizable electrodes which has no actual charge across is the electrode-electrolyte interface. Okay, when the current is applied, we should not have any actual charge present between electrode and electrolyte interface. That is said to be your perfectly polarized. Okay, polarization is nothing but alignment. We are going to align positive and negative charges in such a way that there is no current will be generated out of your cell. Okay, that is said to be polarization. Non-polarization means the current passes freely across the electrode and electrolyte interface. Okay, it requires no energy to make transition. Okay. The material which we are going to get the current is called your AgCl, silver chloride. Okay, and here we have the material called platinum. Your perfectly polarizable electrodes are like resistors, and non-polarized electrodes are called capacitors. Capacitors can charge and discharge as right. Your repolarization and depolarization signal is also like increasing and decreasing, charging and discharging light. Correct. So your non-polarizable electrode is like capacitor. Next comes the electrode and skin interface. Okay, so this is your skin, outer part of the skin. It has three different layers. One is epidermis layer, next dermis layer, and next subcutaneous layer. Okay, so out of this diagram, I'm going to place an electrolyte over the surface of the skin. This is your skin. Okay, so we have paste over here. This is called your sweat duct, and this is your sweat gland. Okay, this is capillary loops, papillae, sweat pore, corium, stratum germinatum, and stratum granulosum. These are all some layers present under your skin. Okay, so what we are going to do is we are going to paste the gel over this place. Okay, the gel electrolyte gel skin surface la poda porom. This is said to be your interface between skin and electrode. Okay, and next comes the electrode skin interface like the electronic circuits. Your placement of electrode and skin will act like an electronic circuit. Okay, so the electrode is a combination of resistor and capacitor. The equivalent circuit of electrode is capacitor and resistor, okay, which is parallelly connected, and the gel acts like a resistor, series resistor. Okay, and your epidermis layer acts like the combination of parallel connection of capacitor and your resistor. This is epidermis layer, parallel combination of RC circuit, and we are having dermis and subcutaneous layer which acts as a resistor. All the sweat glands are having another parallel RC circuit. Okay, this is symmetric circuit. Okay, this is symmetric circuit. One is for your epidermis, another one is for sweat glands. And here we have the same circuit which is equivalent of my electrode. And your gel and dermis subcutaneous layer acts as a resistor. Okay, this is electronic equivalent circuit. Motion artifacts. Okay, what is motion artifacts? Artifacts is nothing but disturbances present in extracting signal out of the human body. Okay, which disturbs the measurement of performance of the organs. And here motion artifacts is nothing but when the person will move or the electrode placement will move from place to place, one place to another, it gives me a motion artifacts. It must be considered while we are placing electrodes over the body. We should consider three things. One is what? Good adhesive connection to the skin. Second, skin cleaning. Third one, floating electrode. Okay, these three must be considered. Good adhesive. Adhesive in the sense the page should be a very effective one, so that the signal will be grabbed from the skin to from the organ to your electrode. Okay, illana the connectivity irukku between your organ and electrode. Seri adukku gel use pandrom. Next we are having skin cleaning. Okay, skin dirt aduchina signals proper irukku, dead cells aduchina signals proper irukku, so that we are going to clean the skin first. Okay, so as you could see, while we are going for some operations and all, the physician used to clean the skin by using some chemicals. Right, so like yellow color la onu thepanga illaya paathirukku operation pandradhukku munadi, so that is used to clean the germs or dirt present in the outer skin. And next, floating electrodes. Electrodes should be a properly sanitized one. Okay, that should not float. Floating is nothing but moving. When the electrode is placed over the surface, it should be remained all the time till the process completes. Okay, if it moves from this place to that place or moving around, then the signal taken out from the organ is not accurate one. So this is how the session will be, and how the electron potential and biosignal potential will be taken, the classifications of biosignal, acting and resting potentials, and the interfaces, electrolyte, electrode interface, all we have studied in this class, isn't it? Do you have any doubts so far? It is like a PN junction diode. Okay, just remember that your cell will gives me signal through electrode. The principle behind that is called PN junction diode. Okay, so when we are going to give some external source, then that cell will excited and it gives me ionic current. The electrode takes your ionic current and converts into your electronic current. It acts like a transducer. Transducer is nothing but it is a device which is used to convert one form of energy into another form of energy. After converting that ionic current into electronic current, I am connecting it to my electronic devices for assistance. Okay, so that I'll get some waveforms and parameter things like temperature, pressure, heart rate, everything out of your organ, and we are going to diagnose how the particular organ will work for. Okay, is that clear? Any doubts? So easy, right? Just have it in mind that PN junction diode, action potential, resting potential, works in the principle of PN junction diode. Right, and next I'm going to ask you few questions. Okay, so I need Kavin Chakravarti. Kavin Chakravarti. Are you here? Kavin Chakravarti. Kavya Darshini. Kavya Darshini. Yes, ma'am. Kavin, answer me the question. List the types of bioelectric potential. Types of bioelectric potential. can chat your answer. Put your answer in the chat box. Resting potential and action potential. Right. Very good answer, Kavin. Thank you. Kavya Darshini, over to you. Define electrode and list its types. What is electrode and types of electrodes? And generator potential. Generator potential two potentials, action and resting the. Okay. Where is Kavya Darshini? Aarti? Aarti, are you here? When I'm calling out your names, just respond. Danuja, Danuja Shri. Yes, Danuja, define electrode and its types. Define electrode and its types. Make it fast. We are going to wind up the session.
Electrodes are conductors.
Okay.
Types of electrodes, cathodes and anodes.
Types of electrodes. Tried well, half answer correct and half is wrong. The electrodes are conductors, okay, which we are going to place over the skin surface to get ionic current. Okay. Types of electrodes are surface electrode, needle electrode. We have studied, right?
Yes.
And those things are types of electrodes. Surface, needle electrode, plain electrodes, okay, suction electrodes, இதெல்லாம் இருக்கு types. Okay, good answer. Thank you. And Abhinesh. Abhinesh. Abhinesh, answer me the question. What are perfectly polarized and perfectly non-polarized electrode? Polarization is nothing but, I'll give you a clue. Polarization is nothing but alignment. Arranging something. Perfectly arranging something or non-perfectly arranged. If it is wrong, let me correct you. No, no.
Perfectly polarized is ma'am.
Sollu.
It's a charge separation, ma'am.
Okay, super.
And non-polarized is no charge separation and is a electrical equivalent.
Okay. Right. So in your perfectly polarized, very good answer, Abhinesh. Thank you. In perfectly polarized, there will be no movement of charges between inside and outside of the cell membrane. Positive charges and negative charges will remain in the same place. Okay, no potential can be taken out. It is like a resistor. Okay, non-polarized electrodes are called as capacitors because there should be a movement between positive charges and negative charges, so that I'll get action potential out of my human body. Okay, non-polarized na movement of ions, polarized na no movement of ions. Right. Define resting potential. Question goes to Charupriti. Charupriti, what is resting potential? Resting potential.
Ma'am, it is membrane potential energy of neuron membrane, ma'am.
Membrane potential of neuron membrane. Resting potential now, your cell will not create any ionic movement, any action, any potential. I mean, voltage எதுமே generate பண்ணாது, ionic movement இருக்காதுன்னு சொல்றேன். Okay, that is resting potential. Well tried, thank you. And next question goes to Gayatri K. நேம்ல இருக்குல்லடா ரெஸ்டிங் பொட்டன்ஷியல், அது ஒண்ணுமே பண்ணாது, சரியா? காயத்ரி கே. இருக்கியப்பா காயத்ரி? Gokul 80. Gokul. Right, action potential is nothing but it is an ionic movement. It has ionic movement in the cell, okay, so that it will create ionic current. Movement of ions. Gokul 80. Super. Good answer, Gokul. Thank you. So this is your today's session. We'll meet in the next class. Okay. Thank you.